Welcome to homework.
So let's talk about thallium iodide or thallium triiodide. We want to know what the apparent oxidation state of thallium is. So we have 3 iodide ions bonded to thallium. Iodide is a group 7, so it will form ions with a charge of -1. So therefore the oxidation state on thallium must be +3. However, given that the anion triiodide actually has a charge of -1 overall, the actual oxidation state of thallium is actually +1. So now we need to draw the shape of the anion and give its VSE PR class and the bond angles. So this is a covalent network of thallium iodide. So we can see that we have a lot of different units of the thallium iodide together in this covalent network. So, however, if we look at one unit, we're actually looking at the thallium bonded to 3 iodide ions. Thallium can be 3 or 4 covalent. It can form 3 or 4 bonds. So, looking further into it, we can determine thallium is the central atom because thallium has a lower electronegativity. So the less electronegativity negative atom is usually in the center. And we find the difference in electronegativity between thallium and iodine is 1.04. So this means it's polar covalent based off of the electronegativity difference. So that means that this is a covalent molecule. So it's not ionic. It's going to have covalent bonds between the thallium and the iodine. So remember that we said that this element could be 3 or 4 covalent. So if we look at thallium chloride as a reference, we find that the thallium is the center atom and does not have any lone pairs on it. So most likely when it bonds with the iodine, it's going to be trigonoplanar. So we can go ahead and draw that. So we're going to have thallium in the center. And then we're just going to have it bonded to iodine. So there is no lone pair. So you can see this is trigonoplanar. So in trigonoplanar geometry, we're going to have 120-degree bond angle. And all 3 of these are going to have the same bond angle. So a reason the compound does not exist as thallium 3 plus bonded with iodine is because of the formation of the iodide or triiodide ion. So the triiodide ion is formed by the reaction between iodine, which has no charge, and iodide ion, which has a charge of -1. So what happens is that these 2 species will combine, and the iodide ion donates electrons to the iodide molecule. And electrons are accommodated by empty d orbitals in order to allow these 3 iodine atoms to bond together to form one ion. So that's why we have the triiodide ion as a single anion with a -1 charge overall that then bonds with the thallium ion with a +1 charge. So if we think about it further, it might be that the ionization energy of the thallium is fairly high, so therefore it would take more energy to remove 3 electrons from the thallium to form the thallium 3 plus ion compared to the energy it would take to form this bond. So it probably has to do with the difference in energy. So we want to conserve energy, and we just want to use the pathway that uses the least amount of energy. So most likely it's just energetically favorable to form this ion versus forming the thallium 3 plus.